Today we're going to talk about something called limited reagents, or you can think of it as a limited reactant. The word reagent just basically means reactant. A reactant, again, is your starting material, and so sometimes you have a limited amount. Kind of like right now we've got a limited amount of toilet paper in the store, so it's going to limit some things. I always start this lesson out with when I was in high school, I worked at Dairy Queen, and so I started out with food. So if you can kind of understand food, then when you get to the chemistry, might make more sense to you. So here are the ingredients to make a bacon double cheeseburger: 1 hamburger bun, 2 hamburger patties, 3 slices of cheese, and 4 strips of bacon. And so those reactants put together would yield our product of a double bacon cheeseburger. And so these are like your coefficients. Those are like your mole ratios going on. So if I were working at Dairy Queen, and many times we would work, it used to close at 9 o'clock and over in the LE area, and about 5 minutes till 9 some bus would drive up with a bunch of basketball boys who were really hungry, and they would want to order the double bacon cheeseburgers. So I look in my closet where we kept our supplies, and this is what I've got left: 12 hamburger buns, 30 patties, 30 slices of cheese, and 36 strips of bacon. And so I've got to figure out how many double bacon cheeseburgers that I can actually make with the correct amount of ingredients before I have to tell someone they can't have one. So if you want to pause for a second, see if you can figure that out, and think about what you would have to do to figure out how many you could make before you have to tell someone that they can have any. So pause the video, see if you can figure it out. Okay, so now we're back, and so what you had to do is you had to take each one of the things that were given, so these were my given values, and figure out how many of these guys can be made. So I'm going to take each one of my reactants, find out how much product can be made. For example, with 12 hamburger buns, and a bun has a top and a bottom, by the way, I could make 12 burgers. I'm not going to write burgers every time. And with the 30 patties, because it takes 2 patties per, I can make 15 burgers. I'll just put B. With the 30 slices of cheese divided by 3, I can make 10 burgers. And then with the 36 strips of bacon divided by 4, I can make 9 burgers. So I figured out how much each one could make, how much each one could make for product. And then, well, I'm never going to get to 15 of these burgers. And the reason I can't get to 15, this can't happen, is because the minute I make 9 burgers, I'm going to be out of bacon. Bacon is going to be gone. And if I have no more bacon, you really can't make a bacon double cheeseburger. I could still make a cheeseburger. I could still probably make a double cheeseburger, but I cannot make it having bacon on it. Okay, I'm not going to be able to make 10. I'm not going to be able to make 12. So the most I can make, this is the most I can make, and this is going to make this what we call your limited reagent. Your limited reactant, the one that you're going to run out of, and when you run out of it, you have to stop making this product here. So the limited reagent, the minute it's gone, in chemistry, the chemical reaction would stop. Okay, these guys here would be your excess reagents. I'm going to have some extra hamburger buns, patties, cheese, etc. So again, to answer this question, I took each one, I found out how much product. The ones that are the bigger numbers, I marked out the one that I can make. The smallest number is the amount you can make of product. So this is my product. In this case, it's burgers. Okay, and then the ingredient that made that smallest number was a limited reagent. I'm going to relate this to chemistry in just a moment. Okay, the next says, how much of each ingredient will you have left over? Well, there's many ways to do it, but the easiest way to do it is to start with the amount of product I can make. I would take, okay, well, I'm going to make 9 burgers. So if I'm going to make 9 burgers, I'm going to need 9 buns, right? Well, I have 12 buns, So can you see that I would have an extra 3 bones? I won't write that down. So I figured I started with the product, I figured out how many I'm going to use, and then I did a subtraction. I'm going to write how many I'd have extra. So this is an extra thing going on. So I'm going to have an extra, what did we say? We're going to have an extra, I'm going to use 9 of them. We're going to have 3 extra buns. Well, if I have 9 burgers being made, but I need 2 patties per, that's 18. So I'm going to have 12 patties left, because I'm going to use 18 of them. If I'm going to use 9 burgers, but I need 3 slices of cheese, that would be 27. That's going to give me 3 extra cheese slices, because 9 times 3 is 27. 30 minus 27 is 3. So I'm figuring how I'm starting with the product, figuring out how much I would use, then I'm subtracting from the original amount. Now if I did this one, 9 burgers, 4 strips, 36, 36 minus 36, you're going to have no bacon. Why are you going to have no bacon? Because that's the limit to reagent. The limit to reagent is the one you run out of. Okay, so that's going to hopefully, if your brain can wrap your head around what I just did with food, when I do it with the chemistry, it'll make sense. Okay, so here we go with the chemistry. So this is in your note page, and so this is just giving you the definitions of limit to reagents. Reagent, again, is a reactant. It's what's going to limit or determine the amount of product that can be formed. The reaction occurs only until the limit to reagent is used up, and the reaction is going to stop. Excess is what you're going to have left over. It's going to be reactants that you've got more than enough, so you've got extra. It's what in stoichiometry I had you marking through because you had plenty of it, so it didn't matter how much you had of it because it wasn't going to stop the reaction. And many times we will, in laboratory situations, we will make sure that we have excess of the cheaper stuff, really, to make sure the reactions always go to completion. So there's our steps. We're going to balance the equations. Should sound familiar, but instead of doing 1 stoichiometry, we're going to do 2 stoichiometries. Actually, we're going to end up doing 3. So if you get lost, maybe you can come back to this page and maybe this will make sense to you, or you can always come back to this video. Alright, our first example. We're going to do 2 types here. We're going to do the smaller mole ones and we're going to do the larger gram ones. So it says sodium chloride can be prepared by a reaction of sodium metal, which just means it's a solid, and chlorine gas, which just means it's a gas, so G. So what will occur if we have 6.7 moles of sodium reacts with 4.2 moles of chlorine? So our first says write a balanced equation. So we are making sodium chloride. Sodium's a +1, chlorine's a -1, so we get NaCl. That's what we're producing. It says prepared. And we're making that from sodium. And you don't have to put solid, but I think Chem 101 is going to require you put solid, so sodium is a solid. And then you've got chlorine as a gas. This is technically a solid as well. And in the Chem 101, they do tell you the states of matter. So then to balance this, we would, hopefully you can see you've got 2 chlorines here. I need a 2 here and a 2 here. So there's my balanced equation. And this is a synthesis reaction. This is a redox. Everything's a redox except for double replacement. Alright, B says, what is the reactant is the limited reagent? Well, I can't just look at those numbers and determine that, because I couldn't just look at the burger numbers and go, oh, 12, you're the smallest number, so therefore you're going to be what I'm going to run out of. It didn't work that way because it depends on how much you use of them. So you can't ever just look at the beginning numbers. You actually have to do some stoichiometry. And believe it or not, even with the burger, you just did some stoichiometry. So we're actually going to do letter B and letter C together, and we're going to be able to answer, we're going to do 2 stoichiometry problems and be able to answer B and C. So it says, what's the amount of product you can make in moles? So if you'll notice, I have a product here and I am looking for it in moles. If you have more than one product, read the problem. It usually tells you which product to go to. So this one only has one product, but the problem usually will state go to a specific product. So notice that I have 2 G's and a W, and that is if you were watching last video where I did the given and wanted. So I'm going to write this down because we're going to be coming back to this. So I have 6.7 moles of sodium, and I'm getting that from the equation there, and it's reacting with 4.2 moles. So this is how you know you have a limited reagent. You've got two given numbers and they're both on the reactant side. So you've got two numbers, both reactants. Limited reagent problem. And then the question's asking me to find what is the amount of product you can make in moles. So I'm going to go ahead and switch colors to moles, and it is NaCl. Alright, so to work these problems, you're going to figure out, just like we did with the burgers, you're going to take each of those starting numbers and figure out how much salt we can make. So I know I'm not lined up very well, but it's kind of hard with these chunky things. Alright, so I'm going to start with this given, and I'm going to go to the wanted. First problem. So I'm going to go 6.70 moles sodium. And I can bring mole of sodium down. The minute mole of sodium is down, I can now switch it, and I'm trying to switch it to sodium chloride. So I'm going to switch it to moles of sodium chloride. This is called the mole-mole ratio, and we get those numbers from that balanced equation. So in front of NaCl there is a 2, and in front of Na there is a 2. So I'm going to calculate this. Hopefully you don't really need to put that in the calculator. It's multiplied by 2 and divide by 2. So this much sodium can get me the same amount of sodium chloride. And hopefully that makes sense because it's a 2-to-2 ratio, so you should be able to see that pretty well. Alright, that may not be my answer, so I'm going to keep going. So our next one, we're going to start with the other given. Bring moles down so I can switch it, and I'm switching it to the same thing that I did up there, so I need to be able to compare the same thing. This is the burgers, and unfortunately this time the product is not burgers, it's sodium chloride. So in this case we've got a 2 here, and in front of chlorine is a 1. So this one can make 8.4 moles of NaCl. Alright, so do you remember in the burger situation where it was the 12 burgers or the 15 burgers? Those were all, they couldn't happen because I was going to run out of something. Well, this 8.4 moles of NaCl, that can't happen either. The most sodium chloride that can be made is the 6.7, because the minute you make 6.7 you're out of sodium, and it's really hard to make sodium chloride without sodium. So my suggestion to you is this larger number. Actually, you just mark through it. That's not the answer to anything that we're going to need. Okay, that can't happen. In fact, this whole little scenario thing can't happen. Alright, none of that's good information. So this is the amount of product that can be made, because that's a product number. That is not the limited reagent. The limited reagent has to be one of these two reagents, reactants, if you want to go for that, one of the two reactants. And it's the reactant that made this smaller amount of product. And the one that made the smaller amount of product was the sodium. Do you see the sodium made the smaller amount? So our answer to question B is the sodium. Technically it's the 6.7 moles of sodium, but I'm okay if we just realize that it's sodium. Sodium is our limited reagent. Not sodium chloride. Sodium chloride's a product. A reagent has to be a reactant. In fact, up here I'm going to label that this is my limited reagent, this sodium right there. That's going to help me keep track of stuff. So if that's my limited reagent, in fact, well, that's okay. I was going to switch colors, but it's okay. That's my limited reagent. This other reactant is my excess. So this chlorine, I'm going to have extra of. This, that's the product that I'm making. Okay. So this next question says, what's the amount of product you can make in moles? Well, I've already marked through the 8.40, so I can't make that. That can't happen. So I'm not going to write that down as my answer. So I've actually got it circled right there, but I'll write it here. So I can make 6.7 moles of sodium chloride. That's how much product can get made. So this is the answer to C, and sodium is the answer to B. On to D and E. D and E gets a little bit harder, and we're going to kind of work this together. So my suggestion to you is to tell you to write this, to always start with the product and work backwards to the reactant. To the excess, I would say. How about we'll go ER, excess reactant. Write that down, and you will always do that for this step. And then for letter E, there's going to be a subtraction. For letter E is going to be a subtraction. All right, so if you wrote that down, I'm going to erase that. We can write. Okay, so we're going to start with the product and work. So let me show you up here on the thing. So we're going to start here and go there. Well, again, we went to this guy, to this guy, this side, this side. Now we're going to work backwards. We're going to start with product and go to the excess reagent. We're not going to go to the limited reagent because I know I'm going to use all of him. I'm going to use all 6.7 moles of Na. So I'm going to work backwards. So I'm going to start with my product. So the product answer was here, 6.7. So I'm going to start. That's where I'm going to start my stoichiometry. 6.7 moles of NaCl. I'm sorry, it's the same number. It just so happens it's the same ratio, but it's NaCl. So I'm starting with the product. I'm answering D and E together here. I'm going to bring moles of sodium chloride down. Where are we going? We just said we're going to go from the product to the excess reagent. The excess reagent is Cl2, and we're going to the mole of that because we need a mole-mole ratio. And so where are these numbers coming from? The balanced equation. For every one of that guy, we are going to get 2 of this guy. Basically what I'm using is if I make this much salt, how much chlorine am I going to use? This is just like I did a while ago. If I had 9 burgers, how much cheese am I going to use? You're going to use 27 slices of cheese for your 9 burgers. If you think of the burgers, that's what I'm doing right now. And so I'm going to use 3.35 moles of chlorine. That's how much will be used. How much will react. That's another word we can use. That's how much is going to be gone. So this is my answer to letter D. This is my D answer. All right. Letter E says, how much will not react? And how much will you have left over? If you go back to the burger scenario, we went back to that original number that we had 30 slices of cheese. But we're going to use 27. So how do you figure out how much you have left over? You subtract. So there's a subtraction. And what are you going to subtract? Well, you go back to the given. Remember a while ago when I said we're going to use that given information? On the given, I started out with 6.7 moles of sodium. I know I'm going to use all of that. That's going to be gone. But I know I have excess of. So go back to the given, and I'm going to say 4.20. I'm answering letter E right now. Moles of chlorine. Okay, so that was given. That's how much you started with. It's like money. You had $4.20. And you're going to use 3.35 moles of chlorine. That's how much you're going to use. That's how much it's going to cost you. You had $4.20, $3.35, and I'm not worried about sig digs here. It's technically a subtraction rule, so you use decimal places. So 0.5 moles of chlorine is what's going to be extra. All right. How are we doing? So we did technically we did 3 stoichiometry problems. We did 2 stoichiometry problems. Found out which reactant made the smallest product. That's the amount of product we would use. The guy that made him is our limited reagent. In this case, it was sodium. And then I started with the product. And I worked backwards to the other reactant because I knew that I had 4.2 of it, but I'm not going to use it all. So I worked backwards to him, and then I did a subtraction. All right, these are the mole ones. We're going to go now bigger to the mass. So take a deep breath, and here we go. All right, example number 2 says if 1.86 grams of chlorine react with 3.21 grams of potassium bromide, then write a balanced equation. So we'll start there. Okay, so we've got chlorine, and there is something special about chlorine. It is diatomic. And we are reacting that with potassium bromide. Potassium is a +1. Bromine is a -1. We always want to check those oxidation numbers. Some of you are missing problems because you're not checking oxidation numbers. This is a single replacement reaction. Go ahead and write that. All right. This is a nonmetal, so that nonmetal would kick out the nonmetal. If it had been metal, it kicks out the metal. So this is going to kick out bromine by itself, and bromine doesn't like to be by itself. It is also one of the diatomics. So instead of being Br, it's Br2. And then potassium and chlorine are going to bond to one another. Potassium is a +1 and chlorine is a, or I should say chloride is a -1. And so you're going to get KCl. To balance this equation, we simply need a 2 here and a 2 here. All right. We're going to begin, and I'm going to put it over here so it's not taking up as much room. A given, and wanted. All right, so we have 1.86 grams of chlorine, and you have 3.21 grams of potassium bromide. And I'm asking for you, what is the limit to reagent? Next question says, how many grams of bromine? See how this has 2 products, so I don't know which one to go to, the question's going to say. So we're going to go to grams of bromine. If it doesn't say, and you were just trying to find limit to reagent, you just go to one of your products. You just got to make sure you go to the same product. All right, this one's mass of one thing going to the mass of the other, so this is going to get long. So we're going to start out with 1.86 grams of chlorine. We cannot go to bromine yet. We've got to go to moles of chlorine. I'll put numbers in a moment. And from moles of chlorine, now I can switch it to, and I'm going to go to bromine, so Br2, and I'm going all the way to grams. So see how I've switched it now. So now we're going to bring moles of bromine down, and we're going to go to grams of bromine. This is the mass. They're the longer type. This is the way they all look. All right, so anytime mole and grams are buddies, mole gets a 1. Over here, mole and gram are buddies, so mole gets a 1. Here, this is the mole-mole ratio. So the mole-mole ratio is where I check the balanced equation. And it just so happens in front of bromine's a 1 and chlorine's a 1. So these aren't always 1. Those guys, always 1. So we've got one of those and one of those because of the ratio. This is going to be your molar mass. It's not just Cl, it's Cl2. So it's not just 35.5, it's 35.5 times 2. So this is 71. This is not just Br, it's Br2. Br is 79.9. So 79.9 times 2 is 159.8. That is the molar mass from Br2. You should be good with molar mass by now. All right, I'm going to multiply, divide. Hopefully you can see all this lovely stuff canceling. And when I multiply, divide, I get 4.19. I left out the 1.19 grams of Br2. All right, not done because I got to do another one. So I'm going to start with 3.21 grams of KBr. Grams of KBr down, mole of KBr. Anytime gram and mole come together, this is going to be that molar mass, 1K, 1Br. That adds up to 119. Bringing moles down, KBr. going to moles. Where am I going? I'm going to the product, taking them both to BR2. Where are these numbers coming from? Balanced equation. This guy has a 1. This guy has a 2. I've now switched to blue. Good thing is the molar mass is the same up there, so I'm taking them both to the same guy, so it has the same molar mass. Alright, I get 2.16. Alright, do you remember before we did 2 stoichiometries? The bigger number can't happen. So this, not useful. Okay. This has 2 of my answers. This is the amount of product I can make, which is letter C. This is my answer to C, which is how many grams of bromine can form. That's my product answer. And then this guy is my limited reagent. So it's asking what's the limited reagent? It is potassium bromide. So the limited reagent makes the smallest product. I'm going to label up here. This guy was my limited reagent. This is my excess reagent. This is my product that I'm looking at. That's also a product. I could have been going to that one, but it didn't ask me to do anything with potassium chloride. But I needed it to balance. Alright, so I've answered B and C. Now D and E. Do you remember how you start? You start with the product, which is BR2, 2.16 grams of BR2. And we are going to work backwards to chlorine. You're not going to go to this guy because you would end up getting 3.21. I guarantee you will. You can try it if you want. I have students like, maybe not. Yes, you do, as long as you do it right. Alright, so we're going to start out with 2.16 grams of BR2. So I'm starting with that product. And I'm working backwards. This is mass. It says, yeah, it says how many grams. BR2. I will tell you if it doesn't say how many grams and you start with grams, you are going to grams on these. Moles of BR2. The good thing is I do have the molar masses all sitting up there staring at me. Alright. Got to decide where I'm going with this. Mole BR2. Where I'm going. Product to excess reagent. So I am going to moles of chlorine. If you label your balanced equation up there, you'll know where you're going in this step. So in this, it so happens to be a 1:1 ratio again. Whoops, should be in red. Going all the way to grams, Cl2. This is 71, and that's 1. I'm going to multiply across the top, divide by the bottom, and I get 0.96 grams of chlorine. So I'm going to use 0.96 grams of chlorine. That is how much will react. This is my answer to letter D. To figure out E, I don't have much room. I'm going to ignore this for just a second. I don't have any room here. Okay, so to go to letter E, how much excess? You go back to, and how much chlorine did you have to start? You are always going back to the given. Okay, so you are going back to the given. I had 1.86, $1.86. I'm going to spend 96 cents of it. So I have 1.86 grams of chlorine in the beginning. That's my start. That's my given. And I'm going to use 0.96 grams of chlorine. And so how much extra am I going to have? It is, notice the labeling. The labeling keeps you straight. So you got 0.9 grams of chlorine. You should not be subtracting things with different labels. Okay, that's going to help you keep your labels straight. Alright, now we're going to do letter F. I'm going to bring F back up so we can see it. It says, if you only made 2 grams of bromine in lab, what is your percent yield? So percent yield, it is how well did you do the experiment. Such as in lab, if you were supposed to have produced 4 grams of something and you only produced 2 grams, then you only yielded 50%. Okay, so percent yield is when you actually do the experiment. So we say actual, which is your lab situation, divided by the theoretical. And that is what stoichiometry says should be being made. And then to make it a percent, you multiply by 100. So if I go back and read that problem, it says you made 2 grams of bromine in lab. So 2 grams of bromine. Notice the ending, Br2, Br2. That's how much we got made in lab. So theoretically is how much stoichiometry said. Well, if I go back and look at all my work, I got a bunch of stoichiometry going on, but I am looking for grams of Br2. Grams. This is not Br2, that's chlorine. That's chlorine, that's chlorine. Go back up, that's chlorine. Keep going. If you'll notice here, this is grams of Br2, but we put an X on it. We do not use that number. We use your product. 2.16 grams of bromine, in theory, is how much we should make. So that's going to go here. Notice the endings are matching there. And so I get, you could do 1 decimal, 92.6% yield. That's a pretty good yield. I'd be happy with that. All right. So hopefully that makes sense to you. I'm going to go ahead and flash the answers to the practice sheet. If you choose to do the practice sheet, there's the correct answers to the practice sheet. There's just 2 problems there. It's one of the mole type and one of the gram type. So they're the correct answers to the practice sheet. All right, please email me if you have questions. Have a good day and stay safe.